This morning I will be speaking on unraveling factors affecting Sclerotinia stem rot in canola, particularly in the light of fungicide spray decisions. As we all know that Sclerotinia is a continuous threat for the sustainability of canola industry Australia-wide. Apart from various cultural practices such as crop rotations and crop isolations, fungicide use remain the principal means of managing Sclerotinia in canola. There are a number of products that are registered for the management of Sclerotinia, but one of the biggest challenge for the industry is the decision to spray. When should be I spraying my crop? As a grower, I will have 3 questions in my mind: whether or not I should be spraying my crop. Secondly, if I have to spray, what should be the optimal timing of spray? And if I spray, will I make any return on my investment? To meet these challenges, we are trying to develop some tools to predict the probability of disease outbreaks in order to enhance growers' ability to make spray decisions. In my presentation today, I will provide you with a brief outline of Sclerotinia levels, what we saw in 2014. I will touch upon the epidemiological studies that we did over the last few years. We did a large scale petal testing in 2014, so we will be presenting some key highlights and with a few case studies from this season, and I will wrap up with some key messages. Okay, so where was Sclerotinia last year? I am sure most of you would wonder, was it there? And if it was there, where was it? So, Sclerotinia was pretty much everywhere. It was quite widespread, but it was not very severe. Despite that, few crops still suffered huge economic losses. We had early opening rains, and that allowed the early development of apothecia, but the conditions were not very conducive for the stem infection development. So, given an average year for Sclerotinia, we estimated that Sclerotinia still did cost the industry approximately $23 million in lost production. Okay, so this is the life cycle of Sclerotinia. I am not going to go through all the details because we all know how the disease starts and the disease cycle. So, what I am going to point out is some of the key stages which are crucial that drive the Sclerotinia epidemics in crops. So, for example, the conditions that are required for the germination of sclerots here to produce apothecia, and secondly, what are the conditions that are favorable post petal infection. So, we have been focusing our research to determine those conditions in order to develop some kind of forecasting system to help growers in making fungicide spray decisions. Okay, so how we can study epidemiology? Epidemiology is the study of environment which is responsible for the development of disease epidemics in our crops. So, there are 3 main ways by which we can study these conditions. We can do spore trapping, we can monitor apothecia development, and we can also have some petal testing. So, we have been trapping spores of Sclerotinia for the last 2 to 3 years, as you can see, by using a normal spore trap, which is 7-day volumetric spore trap. But unfortunately, this technique has proved to be very difficult, and we have not been able to trap sufficient amount of spores so that we can relate the timing of release back to the environmental conditions. And we are now embarking on to look at the development of apothecia, as you can see here. We are trying to look at the effect of locations and also look at the source of inoculum. And one of the third option for us was to look at the presence of inoculum on on petals, the petal infection. This is the most crucial stage in the life cycle of Sclerotinia development, because infection of petals is absolutely essential for the onset of disease, and moreover petal infection also does account for both the external and the internal sources of inoculum. So I am very glad that we continued to study the infection of petals or petal infection over a period of 5 years from 2010 through to 2014 from 6 sites, and we have been continuously recording daily temperature, rainfall and relative humidity. So these are some of the key findings of petal testing. So what we found was both the timing and frequency of petal infection pretty much depended upon rainfall and also relative humidity. These two factors were significantly related with the timing of petal infection. And in terms of air and soil temperature, these two were not significantly related. What are those conditions? I think I will touch upon those towards the end of my talk. Okay, so I just want to give you a few examples from some seasons, the conditions that were really responsible for maximum petal infection in Sclerotinia conducive and non-conducive years. If you look at on the top graph here, so this was the rainfall, mean soil temperature, mean air temperature, and this was the mean relative humidity until we detected maximum petal infection around here. So in a conducive year, as you can see, the rainfall was pretty much in the optimum range, so as the relative humidity, which pretty much stayed between the 18% or maybe 75% here, and that resulted in more than 90% petal infection. And if you look at on the lower side in this graph, you can see right from the beginning, at least within 3 weeks preceding petal infection, you can see neither the rainfall nor the relative humidity were in the optimum range. In fact, right from this point in time, which was around 28th of June, the relative humidity started dropping to a very low, below 40%. So these were pretty much non-conducive conditions for the spore release, or in other words for the petal infection, and no disease developed in that season. Okay, so if you look at the conditions after maximum petal infection, as I said, there are 2 critical stages in the disease cycle. First, the conditions have to be conducive for the spore production, for the spores to be able to cause petal infection, and the second, the most crucial stage is the conditions required post-petal infection. So in a conducive year, again, if you can look at here, at the time when we achieved maximum petal infection here, the conditions were absolutely perfect. Both the rainfall and the humidity were in the pretty much optimal range for the next 3 weeks, and that resulted in a very high levels of disease in that soil. But if you look at in a non-conducive year, there has been a delay before the petals reached, petal infection reached to a maximum level. As you can see here, this is the timing quite late in the season, just around 26th of August. And then conditions were not favorable for the disease development. There was hardly any rainfall, and again the humidity levels were pretty low for the disease to cause a significant problem in canola. Okay, so now you would ask me, what is the role of temperature in our region? So there are a number of reports in literature which point out that temperature plays a major role, and that's true in Europe and some parts of Canada, because in those parts of the world, the temperature goes below even 0 degree or even below, and surely that hinders the germination of Sclerotia and also spore production. But if you look at the mean daily temperature in our part of the world, especially from June through to maybe August here, which are pretty much winter months, and the temperature normally fluctuates between 10 and 17 degree. There may be few instances, few days when it goes below 10, but usually it fluctuates within the optimal range. So temperature is not a limitation for production of spores in our region. Now I move on to the next aspect of my presentation, just trying to give you some of the results for the large scale petal testing that we undertook last year. The aim was to understand the epidemiology of Sclerotinia in southern region, because most of the data we had from the northern region, just we wanted to have more information, especially to understand the conditions in the southern region. It was not aimed at providing you with some kind of forecast in making fungicide spray decisions, but it was for us to understand the conditions, if we have different conditions in the southern region, and that could be utilized later on in development of the forecasting system. So it was a bold decision, a bold call, and we were overwhelmed by response. And we received more than 200 samples encompassing 10 varieties from all over the great southern region. And once we received the samples, we just tried to plate them straight away on selective medium to detect the level of petal infection. So these are some of the key results from the petal testing activity last year. This graph shows the mean petal infection in different shires, and as you can see here, there was significantly high petal infection in Kangura and Franklin, and there was significantly lower petal infection in Katanning. But importantly, what it tells us that inoculum Sclerotinia is everywhere. Every shire we tested, there is presence of Sclerotinia inoculum. Then we try to look at some of the relationship between time of sowing and percentage petal infection. Interestingly, this relationship was not significant, which means that time of sowing had no effect on petal infection. And we've been lucky to manage to go back to about 22 paddocks to assess the level of stem infection, and then we plated stem infection incidence opposite to petal infection, and this is what we found. This was not surprising finding, because there was no relation between petal infection and stem infection. So this was obvious. This was we were expecting. You know why? Because as I just showed you in some of the slides, the conditions post-petal infection must be favorable. They must coincide with the level of petal infection for Sclerotinia to become a problem in canola. So now I take you through to some of the case studies, particularly from last year, especially when it comes to making the spray decisions. So this was the trial we established at Mora. In this trial, we actually try to set this up in a very high Sclerotinia risk, and we applied various fungicide sprays, mainly two products here, Pozaro, which is at the normal recommended rate, and we also included one of the unregistered product. So the aim was to apply fungicide spray at the time matching with the conditions favorable for stem infection. So if you look at the weather conditions in Mora, so this is, in this graph, this is rainfall, humidity, and these triangles indicate the level of petal infection. So right around 13th or 14th of July, we detected the petal infection was around 60%, which was very high. So immediately we decided to spray the trial, which was around here on the 16th of July. So if you look at in the first 2 weeks, the conditions were pretty moderate, not excellent, but moderate for the disease to develop in terms of rainfall and humidity. And after that, there was a dry spell, and we didn't manage to put any, put any fungicide spray after that. So if you look at the results in terms of disease incidence, which is presented in this line here, the disease level in nil plots was moderate, 34%, and these fungicide treatments significantly reduced the disease incidence. However, we got substantial yield response only with the application of Perzaro at this site. So this is the second trial that we did at east of Wagen. So in this trial, I haven't been able to plot the weather data, but we try to apply similar treatments to what we used at Mora. The additional treatment that we applied at this site was Shumislex. We applied that at 1 liter per hectare. So at the timing when we set up this trial, the petal infection was about 59% and the crop was at 50% flowering stage. So what I was able to look back the weather conditions post in petal infection, there was only 17 millimeter rains fell after that. So you can clearly see from this graph, especially in terms of disease incidence, that was just about 13%. So not very much disease developed as a result of conditions not very conducive for stem infection. Again, all these fungicide treatments, they significantly reduce the level of disease compared with untreated, but in this particular trial, Shumislex gave us the highest and significantly higher yield compared with the nil treatment. Okay, so this is the trial which I am going to present. This was we conducted at East Chapman. In this particular trial, we tried to look at the effect of row spacing, Perzaro, and plant density with their combination to investigate the level of Sclerotinia with all those factors. So if you look at on the left-hand side in this table, all these treatments are listed in this column, and this column shows the disease incidence, and this column here shows the yield per hectare. So various treatments in this trial were Perzaro versus nil. We applied the treatment at 30% flowering. We had two varieties here, Cobra and Hyola, just to represent the open pollinated and hybrid varieties. And the row spacing, we had like narrow and wide row spacing, not really narrow, but I would say normal row spacing. And we had two plant densities, 15 and 30 plants per square meter. So if you look at the results, fungicide treatment at 30% flowering gave us just significant reduction in disease, although it doesn't look significant from the LSD, but this is non-transformed data, but if we had arc sign transformations, this effect was significant. And also, this effect was translated into yield. So we got positive yield response of the order of 0.2 ton per hectare. In terms of varieties, of course, hybrid had a significantly higher disease compared with open pollinated, but contrarily, the hybrid performed much better. We had a highly significantly higher yield in a hybrid variety compared with the open pollinated. Row spacing had absolutely no effect on disease incidence, but the trend was for a higher yield with wide row spacing. With plant density, again, no effect on disease incidence, but high plant density, 30 plants per square meter, gave us significantly higher yield. So in this trial, we estimated the return on investment was about $50 per hectare. And if you look at the weather conditions at Chapman Valley last year, so this is the timing where we detected high level of petal infection. Straight away we put fungicide on, and if you look at the conditions were pretty much favorable, not very favorable, but moderately favorable, I would say, in the first 2 weeks here. So that's why we got positive yield response here. But had I decided to put another spray here, which most of the growers did, I would have lost all the benefit that I made here. So in the conclusion from this work is, last year we never needed 2 fungicide spray. 1 fungicide spray at the right timing was perfect for the disease reduction and also have some yield response. Okay, so finally, coming to the crunch time, this is the thing which every grower wants to know, decision to spray. Of course, decision to spray depends upon a number of factors, not only one. One of the most important factors is the presence of inoculum. You must have a history of Sclerotinia on your farm. And secondly, we have to have conditions favorable for petal infection, and also the conditions should be favorable for the stem infection. And also we need to look at the yield potential of the crop, cost of fungicide and its application, and of course, the current canola prices. But having said that, the decision to spray in our current scenario boils down to these two conditions. What are these conditions? So after working so hard for 5 years, I am very pleased to say that we have identified those triggers. So what are those conditions? More than 40 millimeter of rainfall and more than 75% of relative humidity prior to petal infection, which leads to the production of spores, and same conditions, greater than 40 millimeter rainfall coupled with greater than 75 relative humidity is required for stem infection. Okay, where to from here? Now, as I just mentioned, we have found the much desired triggers. This is the much needed information for the industry. And I think I could say that now we are very close to developing our WA's very first Sclerotinia forecasting model, WA Sclerocast. So what we are trying to do in the coming months, we will try to focus on providing you with some regional risk forecasts. Either we can provide you some with the regional risk maps or some other form, and we will continue to validate these findings and also the model that we develop during the coming few months. And one of the other aims for us is to develop a yield loss model, because I think this is the thing which is needed by growers for them to really make fungicide spray decisions. And the ultimate aim is to develop Sclerotinia e-guide, a one-stop shop where growers can find every information they need to have for managing Sclerotinia. Okay, so I wrap up with some of the key messages. So these findings have led to a significant breakthrough in understanding the triggers for Sclerotinia development, which are greater than 40 millimeter rains and greater than 75% relative humidity in the 3 weeks before and after early bloom. And certainly, temperature has absolutely no role under our region. It doesn't play a vital role in the epidemiology of Sclerotinia. And we are very close to developing Western Australia's own Sclerocast, and which is, I'm very hopeful that it is on the way. So in the end, I would like to acknowledge Grains Research and Development Corporation for funding this research, and would I also thank my whole team for their contributions towards this work. As you can see their names, and particularly I would like to thank John Paul Collins and Jeremy Lemon, especially for sending a lot of samples for petal testing. And I would like to thank our research support units, and especially I would like to mention Ashton Gray, David Cameron, and Tim Scott for their help with setting up some of the trials, and would also like to thank several WA canola growers who allowed me to have my trials on their property. Thank you for your attention.